In the Middle Ages, alchemists were chasing a dream that seemed impossible, transforming ordinary lead into dazzling, shining gold. Although it may seem a bit naive to us today, they devoted their entire lives to this idea. History books often portray them as strange, obsessive old men. But there was one thing they didn't know. Their dreams were not actually that impossible. Yes, today we know that gold can really be produced. But the secret is not hidden in dark laboratories. It lies much farther away. So, how did the story of gold on Earth begin? Did it emerge spontaneously over time, like oil trapped in rocks? The truth is a little more complicated than that. Gold doesn't even truly belong to Earth. It was born in the heart of the universe's most violent events and reached Earth billions of years ago from the depths of space. Imagine, the things we wear as jewelry are actually the last remnants left to us from the universe's most violent explosions. But how does a journey that begins in the heart of a star reach a tiny ring on our finger? Now, come with me, and let's explore together the incredible story of gold descending from space to Earth. To understand the story of gold, we first need to unravel the nature of stars. Because everything begins with hydrogen, the universe's most fundamental building block, found in the heart of a star. In young stars, almost the entire core consists of hydrogen. After all, this is also the fuel for the first fusion process. Despite being the simplest and lightest element in the universe, when hydrogen gathers in enormous quantities and under the pressure of gravity, it collapses inward. In the core, temperatures reach millions of degrees, and pressures reach unimaginable levels. This process initiates a magnificent phenomenon at the heart of stars: nuclear fusion. Simply put, it is the process of atoms merging. Normally, atomic nuclei repel each other, but under these extraordinary conditions, that repulsive force is overcome. Hydrogen nuclei fuse together to form helium, and the enormous energy released allows the star to shine its light across the universe. And this process is so powerful that the fusion taking place in the core of the Sun transforms billions of hydrogen atoms into helium every single second. The energy released in just 1 second far exceeds all the energy humanity has ever produced. That's why stars act as the true energy factories of the universe. But nothing lasts forever. Over time, stars grow old. When the hydrogen in the core is depleted, the helium that was once created by its burning now becomes the new fuel. When helium begins to burn, carbon, oxygen, and progressively heavier elements start to appear. Each newly formed element then becomes the fuel for the next, continuing the chain. The star works like a cosmic furnace, producing different and heavier elements at every stage. But here's the interesting part. Each new fuel burns much faster than the last. The star's lifetime turns into an accelerating countdown, and when the process reaches iron, everything suddenly stops. That's the end of the road for the star, because producing iron doesn't release energy like other elements do. On the contrary, it consumes energy. In other words, the star can no longer generate power within its core. At this critical moment, the core can no longer support its own weight. The outer layers rapidly collapse inward, then violently rebound outward, triggering an enormous explosion, a supernova, one of the most violent and spectacular events in the universe, so bright that a single supernova can outshine most of the stars in our entire galaxy. Sometimes it can even be visible to the naked eye for days or even weeks. At the heart of this explosion, a completely different scene unfolds. The pressure here is so immense that protons are forced to merge with electrons, forming neutrons. And at that very moment, the universe's heavy element factory begins to operate. Gold, platinum, uranium, many of the elements we consider rare and precious on Earth are actually remnants of a dying star. Neutrons have an interesting property. They carry no electric charge. That means elements like iron can easily capture them. And because of this, through the rapid capture of neutrons, elements that a normal star could never produce begin to form. Silver, gold, platinum, even massive atoms like lead and uranium. The most astonishing part is this. While the transformation from hydrogen to helium takes millions of years, the creation of these heavy elements during a supernova lasts only a few seconds. The universe's most valuable treasures are born in the blink of an eye. So what happens next? The enormous shock wave from the explosion hurls these fresh elements into interstellar space. Gases and dust scatter in all directions, forming enormous clouds that twist, mix, and collapse under gravity. Over time, these clouds give birth to new stars and planets. So before gold ever accumulated in veins deep within the Earth, it was first forged in supernovas and neutron star collisions, and then carried to our planet billions of years ago on the backs of meteorites. But this journey doesn't end once it reaches the Earth, of course. As the planet's interior churned, underground activity slowly brought this precious metal toward the surface. Then, over millions of years, it accumulated in veins within the Earth's crust. Humans began to extract and process this gift of the great geological process through mining. But even knowing this is fascinating. Gold is so dense that it is about 20 times heavier than water. Yet, if humanity were to gather all the gold ever extracted from the Earth throughout history, it would only fill about 3 to 5 Olympic swimming pools. Thousands of years, countless workers, enormous machines, shovels, and in the end, just a few pools of gold. This clearly explains why gold is so valuable. But its value isn't determined solely by its rarity. Of course, gold has its own incredible properties. For example, it does not rust, tarnish, or decay. That's why gold placed in pharaohs' tombs thousands of years ago can still appear almost as shiny as it was on the first day, a metal that seems to defy time. Additionally, it is very malleable. Just 1 gram of gold can be beaten so thin that it becomes almost like a sheet of silk, covering an area of approximately 1 square meter. This is why gold becomes indispensable in artworks, jewelry, and at the heart of electronics, in the circuits of our computers and phones. But can we produce more of this shiny metal? In theory, yes, it is possible. Particle accelerators allow us to replicate the complex nuclear reactions that occur inside stars. However, there is a fun and somewhat tragicomic side to this. These machines cannot produce gold in scoops or ingots, but atom by atom. In other words, producing just 1 gram of gold would require a waiting time almost as long as the age of the universe. And the cost of doing so is so astronomical that even if you were Elon Musk, you would probably avoid it entirely. So yes, it is theoretically possible, but in reality, it's practically useless. What if all the gold on Earth were to run out one day? Then we would have to turn our eyes elsewhere, for example, the oceans. Scientists estimate that about 20 million tons of gold exist dissolved in the seas. Sounds incredible, right? But here's the catch. The gold is so diluted that if you filled an entire Olympic swimming pool with seawater, the amount of gold in it would be only a few grams. And it would be so evenly dispersed that picking out a single particle would be impossible. So that 20 million tons is spread across the oceans, requiring liter by liter processing. And for now, the cost would be thousands of times greater than the value of the gold extracted, making it practically meaningless. Maybe one day technology will advance and extracting gold from the seas will become possible. Or maybe it will never happen, and we will look even farther, for example, to the asteroid belt. Astronomers believe that some asteroids may be richer in gold than all the reserves on Earth. Imagine if we reach these rocks one day. The concept of gold's rarity could disappear entirely. Perhaps gold jewelry will become merely nostalgic keepsakes. And just imagine massive mining ships floating in space, robotic arms clinging to asteroid surfaces, rocks being processed with lasers. Future gold hunters not wearing cowboy hats, but space suits this time. Humanity's new gold rush will not take place on Earth, but among the stars. If you've watched this video this far and learned something, you should know that your support on my newly created channel really means a lot to me. Don't forget to like, subscribe, and share your thoughts in the comments. As long as you show your support, I'll keep working to create even more content. Thank you for watching, and see you on the next journey.